Welcome to our first number sense video. In this example, we're going to learn to decompose numbers additively. Let's read the problem carefully. Deb and Frank pooled their money together and had a total of 10 $1 bills. Determine all the possible amounts they may have originally had if they each had at least $1. You do not need to distinguish between who had what amount. Just write $1 and $9. You do not need to write Deb had $1 and Frank had $9 or vice versa. So notice up in the right-hand corner, I have written givens, yellow, goals, blue. So it's a good practice in mathematics problems to identify the information you're given and the goal, which is what you want to find. So let's go to our problem and see what we were given. So we know they pooled their money together and they had a total of 10 $1 bills. That's our given information. We're also told down here in parentheses specific about the problem that we do not need to distinguish between who had what amount. So that piece of information will be useful when we're solving. So now what are we solving? What are we trying to find? That's our goal, and we're going to highlight that in blue. Usually in a math question, the goal begins by asking you a question. What is, find out, or determine is another good first word, or sometimes solve. In this case, we see the word determine, and that tells us what we're trying to find. Determine all the possible amounts they may have originally had if they each had at least $1. So now we've determined what we're given, what we know, and what we're trying to find out. So notice that there are 10 $1 bill signs or dollar bill signs down here, and each one represents a dollar bill. You should write this in your mini lesson packet because we're going to be using it to solve this problem. Frequently in this course, we're going to be using visual aids to help you understand the concept behind a problem and get a better grasp of it. So you should always include them in your packet. I also have a table ready. It says first person and second person, and this is where we're going to organize our information, all the different amounts that they may have originally had. So let's get started. So you might want to first start thinking about, well, what are a couple of ways this could happen? Well, maybe the first person has $3 and the second has $7, or maybe they both have $5. And that's a good way to get your brain started, but we really want to use some sort of systematic method to solve this problem. So if we don't use a systematic method, something could happen where maybe we skip a possible answer, or perhaps we repeat more than one answer more than once. So we're going to really take this step by step. So since they said they each have at least $1, I'm going to start where I'm going to draw a line here, and this is going to separate how much the first person has and how much the second person has. So I'm going to label them 1 and 2. So if the first person has $1, the second person has $1, 2, 3, 4, 5, 6, 7, 8, $9. I'm going to put that in our table. 1 and 9. Okay. Now I'm going to shift to the right and put our partition line here. So for this one, we have the first person has $2 and the second person would have the remaining, or $8. So we have 2 and 8. Let's continue on. I'm going to put our partition line here. Here we have $3 and here we have $7. So that's a possibility. And you may start to see a pattern now. So notice in our table, we're incrementing the first person's amount of money by $1. That way we know we're not skipping any possible outcomes. And as we do that, the second person's amount goes down by $1. Notice each row also adds up to 10, which is a total number of $1 bills. So you probably know what we're going to do next. We're going to move this line over to 4, and we have $4 and $6. Let's keep going. 1, 2, 3, 4, $5 and $5. And you may be starting to think, is this ever going to end? And that's something we're concerned with. When do we stop? When do we know we've found them all? Well, let's just continue and see what happens. So I'm going to move this to the sixth spot, 3, 4, 5, 6. And notice this would give us $6 and $4. But notice, if we go back to our chart, we already have a combination that has 4 and 6 in it. Granted, it's in the other direction, but remember the direction said you do not need to distinguish between who had what amount. So 4, 6 is the same as 6, 4 in this problem. So here we could actually stop. This would be repeating a solution, which we don't want to do. So we found all of the different answers. Okay. Notice, I'm going to write this in red, and then we'll take it away. If we had continued to write 6 and 4, which we're going to erase in a minute, then the number on the right would be smaller than the number on the left. And notice that's when we know that we've gone too far, because if this number is smaller, that means it would have been in the first person column already. Continuing in this manner would just basically switch these columns. So we'll erase those because they are not solutions. And now let's write our final answer. So we've shown all of our work, but we want to make sure that we're clear about what our final answer to the problem is. So I'm going to put 1 and 9 in commas. I'm going to leave a little space between them, or else there'll be too many commas. It'll be hard to tell which is which. So we have 1 and 9, 2 and 8, 3 and 7, 4 and 6, 5 and 5. And those are all of our possible combinations.